Okay, so let's see if you have all the math skills required to solve this problem. Matter of fact, let me go ahead and read this lovely math word problem right now. So, a ship is going 10 knots and it is turning 180 degrees with a radius of 800 yards. So, how long will this turn take? Okay, so some of you might be confused about what's going on in this problem. So effectively what we have is a ship. Now this ship, let's suppose, is going due north and its speed is 10 knots, right? This is how we like to measure speed out at sea with in terms of boats and ships. Now this ship wants to do a full U-turn, let's say go due south. So it has to do a 180-degree turn. Now, this part of the problem, this radius, you can see here we have like a semicircle. So the ship is going to form a semicircle. Now, the radius of this circle is 800 yards. We call that the turn radius of a ship. Now, the question here is how long will this turn take, right? So once this ship starts to conduct its 180-degree turn at 10 knots, how long is it going to take? Of course, we have to use all this information, and there's going to be a lot of different skills that you need to know in order to solve this problem. And you're also going to need to know some conversion factors. So let me show you this right now. So the first is in terms of knots, okay? 1 knot is equal to 1 nautical mile per hour. Okay, so we don't like to use miles per hour in terms of speed. We like to use knots. Okay, so out on the ocean with ships and boats, it's knots, not miles per hour, kilometers per hour. So 1 knot, again, is equal to 1 nautical mile per hour. So just real quick, so for miles per hour, that is 1 mile per hour, right? So we just write that mph, but a knot is equal to 1 nautical mile per hour. Okay, so that's that. Now, 1 nautical mile is going to be equal to 6,000 feet. Now, actually, 1 nautical mile is a little bit more than 6,000 feet, but for navigation purposes, a lot of people, like the U.S. Navy, just will kind of round it off to 6,000 feet. That's very, very common. And then 1 yard is equal to 3 feet. Okay, so this is the question, and this particular problem is actually near and dear to my heart because in a former life, I actually was a U.S. Navy surface warfare officer. In other words, I actually drove ships, big old Navy warships for a living, and that was a fantastic part of my life. It was, really was a true adventure. And my last tour was actually a navigator on a very big ship. So it was just a great way to apply my, mathematics training. But driving ships is a lot of fun. It's way well for me. Driving a small little boat, yeah, that's pretty. That's fun. But definitely doesn't compete with driving huge warships. And this is a pretty typical type of problem that we would actually have to calculate. Now, here's the thing. Out at sea, when you're doing this stuff, when you're the officer of the deck, there's all different sorts of little rules and type of things that you can use, little kind of like shortcuts. But in this particular problem, we're just going to walk through step by step and go through all the math in order to solve this problem. Okay, so with all that being said, go ahead and figure this thing out. And if you have the answer, well, put that into the comment section. I'm going to share the correct answer in just 1 second. Then, of course, we'll walk through this entire solution to this problem. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so hopefully everyone has a sense of what's going on here. Remember, this ship is doing a full U-turn, and of course, this is like a semicircle, and the radius of this semicircle is 800 yards. The speed of the ship is 10 knots, and of course, we're assuming that the ship is going to maintain its speed through this full turn. We want to know how long it's going to take to conduct this turn. Okay, so let's go ahead and take a look at the answer. Basically, these would be the two most common answers, 0.1256, approximately 0.1256 of an hour, or approximately 7.536 minutes. Okay, so if your answer is somewhat close to one of these numbers right here, well, that indicates to me that indeed you did this right, and I have to give you a nice little happy face and A plus plus, a 150%. Matter of fact, I would just give you an honorary surface warfare officer pin, and this is a very terrible kind of rendition of a pin that it's basically like pilot wings that we would qualify for. And for myself, it took me a couple years, and that's pretty much on average, to earn, effectively my sea wings. But anyways, I just love being out on the ocean. It's been some time for myself because out at sea on ships, it's like one gigantic math word problem. You're doing navigation problems. There's engineering going on. Anyways, I don't want to digress too much, but if you got this correct, this problem correct, well, that is fantastic. And now let's go ahead and get into the actual math required to solve this problem. Okay, so first things first. First, we are dealing with a math word problem. So always use the rule of three. Read the problem at least 3 times before you start doing anything. But in this particular problem, you have to understand kind of the terminology. So we have the radius at 800 yards. We're dealing with the ship, where we have knots. So if you don't understand these things, well, you need to kind of ask what's going on. But this is a perfect situation to model this information. So once you read the problem a few times, what you want to do is visualize it or model the situation so you can kind of start looking or trying to envision the actual solution to the problem. Okay, so let's go ahead and take a look at a nice lovely sketch of what's going on. So here is our ship. It's going 10 knots and it's going to conduct a 180-degree turn. All right, so in other words, it's like going due north and it's going to end up going due south. And the radius of this turn is 800 yards. All right, we call this the turn radius because you can see that our ship isn't going to kind of do like a parabola or some kind of weird thing. It's not going to turn around like this. It's going to put on its rudder, right? So maybe a standard rudder or full rudder or whatever the case is, and it's typically going to hold it. It's not going to do something like this. Now we have to kind of simplify this problem because some of you out there that maybe have some maritime experience could be like, well, there's different scenarios here, but we're just going to hold this turn and we're going to do 180 degrees just like this. All right, so this is the scenario. And now really what we want to figure out is how long it's going to take for this ship to complete this turn. Okay, so we need a strategy here, and we're going to need a few different formulas, but the first thing we need to understand is that we're dealing with a rate, time, and distance. This is effectively a motion problem, and you can't solve motion problems in math unless you understand this equation right here. Okay, now some of you out there are math students. You absolutely need to commit this to your long-term memory. And if you're not a math student, well, this is another excellent formula to just commit to your long-term memory. I think everyone should kind of know this. So what is this formula? Well, it's very straightforward. It's rate times time is equal to distance. Rate times time is equal to distance. Not a difficult formula, but let's take a look at an example because if you don't use this formula correctly, you'll get the wrong answer. Okay, so let's suppose we have a lovely car here. Let me just kind of draw a little car. And this car is going 60 miles per hour. Okay, so how far will this car go in 2 hours? Okay, so this car is going 60 miles per hour. In 2 hours, it's going to cover what? It's going to cover 120 miles. So the rate is the speed. Okay, so rate times time. Again, rate is the speed or the velocity of something. So in this particular case, it's a car. And we have to be very, very mindful of the units of measure here, okay, because this is really going to be the key part of solving our problem with our ship. So we have 60 miles per hour. All right, so this is miles per 1 hour, right? So this car will go 60 miles per 1 hour. So How far is it going to travel in 2 hours? Well, if it goes 60 miles in 1 hour, in 2 hours, it's going to go 120 miles. But let's notice here that we're multiplying by hours, right? Multiplying by hours. So we are going to be cross canceling these units of measure, hours and hours. We're going to be left with miles. So we have to be very aware of units of measure here. And our problem here with this ship, we're going to have to convert some units of measure to figure out what's going on. But this is the formula that you need to understand. Rate times time is equal to distance because this is a motion problem that we're dealing with in this ship. All right, so this is a simple example. Hopefully you know this formula, but if you didn't, well, there you go. Okay, so now let's go to continue on with the problem. And thinking about this problem now, we're like, all right, well, rate times time is equal to distance. So what is the rate in our problem? Well, the rate in our problem is the speed of the ship. Okay, so just like the car going 60 miles per hour, our ship is going 10 knots or 10 nautical miles per hour. So we don't write like, mph. This is miles per hour. A knot means 1 nautical mile per hour. Okay, so I'm kind of breaking this down nice and clear for you. So if you're confused, you can, do these problems in the future or just be familiar with knots because, these problems do come up, particularly when dealing with like ships or aircraft, airplanes, whatnot. They use knots as well. Okay, so our rate is 10 knots. Our distance is what? Well, our distance is this distance right here. Okay, so this ship is going to have to cover this distance. It's going to start here and it's going to go through this 180-degree turn. So it's going to have to travel this entire distance. Now you can see here that we're dealing with a semicircle and the radius of this circle is 800 yards. So I'm kind of giving you a lot of clues here. So we're going to have to figure out what this distance is because the question is what? How much time is it going to take this ship going 10 knots to cover this distance? So we're looking for T. Okay. Now we're going to have to be very, very aware again of our units of measure. We have yards here, and here we have knots. And knots again are what? That's 1 nautical mile per 1 hour. Okay, so I gave you some conversion factors in the beginning of this video. You're definitely going to need them. And there's a couple different ways you can approach this problem, but we're definitely going to have to convert units of measure. And if you're not good, if you're not, let's say, skilled at converting units of measure, you can easily get confused in this problem. Converting units is absolutely a critical skill in mathematics and in science. But let's go ahead and continue on with the problem and hopefully understand what's going on here in terms of the strategy, right? So the strategy is what? Well, we know the rate, it's 10 knots, okay, of the ship. So we're going to have to calculate the distance of this turn, okay? So we're dealing with a circle. So the distance around a circle is called what? It's called the circumference, right? So what is the formula for the circumference? Well, we have, again, another formula that we're going to need to know in order to do this problem. So the circumference of the circle, circumference of a circle is equal to 2 pi r, or the diameter times pi. Okay, they're equivalent. So because we have the radius, r is the radius, we'll use this version of the circumference formula. Okay, so the circumference again is the total distance around a circle. Well, here we're not going to be going the full distance, right? We're only going, halfway around 180 degrees. So we're only going to be covering a semicircle. So again, I'm kind of giving you hints here for those of you who are like, I think I know what to do, Mr. YouTube Math Man. So if you feel at any time you're like, oh, I got this, you should pause the video and try to figure out, the rest of the problem on your own. Of course, I gave you the answer, but you can see, hopefully kind of reconstruct my answer. That's the best way to learn math is once you figure out, oh, I get it, you should try to finish out all on your own. Okay, so here is the situation. Again, we know the rate, and we're going to have to figure out the distance, and we have yards. So we have to make a decision here. So we can calculate this distance here, the circumference, using yards. But if we calculate this in yards, well, we're going to run into a bit of an issue in terms of using our formula. okay? Because our formula, we have knots here, right? So knots is dealing with what? That's one, this is a 1 knot, again, is 1 nautical mile per hour. So what's the unit of measure for distance? It's a nautical mile, not yards, right? So we're going to have to kind of pay the price one way or another to in terms of converting. So let's go ahead and convert these yards into nautical miles, and then we'll calculate this distance in terms of nautical miles. So first things first, we're going to have to figure out what 800 yards is equal to in terms of a nautical mile. Okay, so here is our problem. So we're going to, again, use our conversion factors. So 1 nautical mile is equal to 6,000 feet. So again, some of you might say, hey, I looked this up on the internet. It's actually over 6,000 feet. Yes, indeed, I understand that. But a lot of people that drive ships, navigators, whatnot. It's pretty common. People, we just use 6,000 feet. It just makes calculating things much easier because out in the ocean, when you're doing this stuff in real life, you're not looking for perfect answers. You're just doing quick calculations. So again, 1 nautical mile, we're going to be using 6,000 feet, or 1 nautical mile is equal to 6,000 feet, and 1 yard is equal to 3 feet. It just makes all the math a lot easier. Okay, so we need to figure out how many yards. Okay, this we have 800 yards. We want to convert it to what unit of measure? Well, we want to convert those yards into nautical miles because we have 10 knots or 10 nautical miles per hour. So we're going to go from yards to nautical miles, right? Okay, so how do we do that? Well, we're going to use these conversion factors. So first things first, let's get rid of yards, and because we have feet right here. So anything that you don't understand, I'll give you some suggestions on how you can improve in converting units of measure. But there's 3 feet to 1 yard. Now, why I'm writing this way, not 1 yard to 3 feet. This is what we call, again, a conversion factor. So this is the actual conversion, okay? But this is the conversion factor because I'm going to multiply this times this. And when I do that, I get rid of yards, okay? Because this is just one fraction, and I'm left with feet. All right, so how many feet is 800 yards? Well, 800 times 3. Okay, so that's that. But I want nautical miles, so I'm going to have to get rid of feet. So 1 nautical mile is 6,000 feet. So again, this is our conversion factor. So I can cross cancel feet, and I'm left with nautical miles. So the math here is going to be 800 times 3 divided by 6,000. This is how many nautical miles we have. All right, so let's go ahead and do this right now. So 800 times 3 over 6,000 will give us 800 yards converted to nautical miles. So 800 times 3 is 2,400 divided by 6,000 is going to be, we could simply just reduce this fraction. That's 24 over 60, or 2 fifths. All right, now again, in the beginning of this video, I said definitely use a calculator. So let's convert this 2 fifths to a decimal. So 2 divided by 5 is 0.4. So 800 yards is 2 fifths of a nautical mile, or 0.4 of a nautical mile. And we'll just use the 0.4 of a nautical mile for this problem. Okay, so again, a lot of different work kind of going on here, and now we can actually calculate the distance this ship traveled. But before we do that, I'm going to ask you to do this, and that is to quickly subscribe to my YouTube channel. I definitely need your support. I love putting together videos like this, but they take me a good amount of time. First of all, I have to, I have to think to myself, and here is a little picture of me thinking. I'm like, all right, what would people be interested in? And I try to spread it around from basic math to advanced math to geometry, trigonometry, algebra, the whole 9 yards. And a lot of the word problems I come up with, I try to make extra, kind of creative, and and also where you're going to actually learn something, right? Not so easy where if you don't feel challenged enough, you're not going to watch these videos, because the whole idea behind my channel is for you to learn math. And if you're going to learn math, you should apply math to solve problems. But anyways, I definitely need your support. And the best way to support this channel is to hit that subscribe button. And if you're going to do that, hit that notification bell as well so you can get my latest videos. All right, so let's get back to this problem because we still have a decent amount of work to do. But again, as I promised, there is a lot of different math skills involved in this problem in terms of figuring out the solution. Okay, so again, we have our formula here. This is a rate, time, distance, motion problem. Our rate is what? It's 10 knots. Our distance is this distance right here. Okay, now we're thinking in terms of a circle. So this full distance around a circle is the circumference, but we're not doing the full distance. We're only going halfway around this circle, okay, i.e. a semicircle. So we have this 800 yards, but we decided to convert the 800 yards into nautical miles because we're going to have to use nautical miles because we have 10 knots or 10 nautical miles per hour. Okay, so our radius is zero point 0.4 nautical miles. And again, the distance is not the full circumference around a circle. Okay, the circumference, this formula here is going to tell us the distance. If this ship just did a full, like circle in the water, then that would be the distance, but it's only doing a semicircle, so it's doing half of the circumference. So this, we're going to take the circumference and we're going to divide it by 2. So 2 pi r divided by 2, the 2's cross cancel. So we just need to figure out what pi times r. Of course, r is the radius, and the radius that we're using here is in nautical miles. All right, so the circumference divided by 2 is a semicircle, so it's pi times r, so that's going to be pi times 0.4 of a nautical mile. And we're going to use 3.14 as a rough approximation for pi. So pi will pi times 0.4 or 3.14, again, rough estimation for pi. So 3.14 times 0.4 is approximately 1.256 nautical miles. Okay, so that was a decent amount of work to figure this part of the problem out. So our situation now is the following. Okay, so we have our ship. It's going 10 knots, and it just covered, it was going to have to cover 1.256 nautical miles to do this 180-degree turn. Now the question is, how much time is this turn going to take? All right, so now we have our rate, okay, and now we have our distance, which of course is 1.256 nautical miles, and we're dealing with nautical miles and nautical miles per hour. So our answer is going to be in what unit? It's going to be in hours. So let's go ahead and do that part of the problem right now. Okay, so here is our formula again. Rate times time is equal to distance. So what is the rate? Again, it's 10 knots or 10 nautical miles per hour times what times time is equal to the distance. And the distance it traveled or the ship traveled is 1.256 nautical miles when it did its 180 degree turn. Okay, so we need to solve this basic algebraic equation for t. So we're going to divide both sides of the equation by the rate. Okay, but we can kind of see this better this way. All right, so here is our setup. So we have 10 nautical miles per hour times t, which is the time, that's what we're looking for, is equal to 1.256 nautical miles. So the best way to do this algebraically is just to simply multiply both sides of the equation, which is the same thing as dividing by 10 knots. But I'm going to multiply both sides of the equation by the reciprocal, okay, because 1 hour over 10 nautical miles, the reciprocal, I'm just flipping this upside down. What happens here? Well, the nautical miles cross cancel with nautical miles, hours cross cancel with hours, okay, and 10 is going to cross cancel with 10, so that leaves us with just one big T, or one T, which is what we're looking for, right? So that is how we're going to solve on the left-hand side. And then on the right-hand side, because I'm multiplying by 1 hour over 10 nautical miles, right, I got to multiply this side of the equation by 1 hour over 10 nautical miles, and look what's going to happen. Our nautical miles are going to cross cancel, and I'm going to be left with hours as I should be left with, right? Because I'm dealing with nautical miles per hour, all right? That's what 10 knots are. So a lot of moving parts to this problem. Again, if you don't understand conversions, it's easy to get confused. All right, so let's actually do the math here. So we have 1.256 times 1 over 10, or 1.256 divided by 10. So 1.256 divided by 10 is equal to 0.1256 of an hour. Okay, so that is the answer, but really, that doesn't really kind of make a lot of sense to us. We're like, oh yeah, 0.1256 of an hour. What does that really mean? Well, let's think about this in terms of minutes. So we have to do another conversion. All right, so 1 hour is equal to 60 minutes. So if this turn took 0.1256 of an hour, well, it took 0.1256 of 60 minutes. So we'll just multiply that 0.1256 times 60 minutes, and we're going to get approximately 7.536 minutes. Okay, so that's how long, more or less, it's going to take this ship going 10 knots to do a full U-turn with a turn radius of 800 yards, about 7.5 minutes. Okay, so that is that. And, if you looked at this problem and you're like confused and now maybe you're more confused, well, don't get confused. The whole idea here is to try to appreciate the fact that there's going to be a lot of problems, in mathematics where you're going to have to use a lot of different skill sets and a lot of different formulas. But one thing is for sure, and this comes up not only in math but in science as well, you need to know how to convert units of measure. Okay, and a lot of people really don't know. They're not strong enough in that particular skill. So, if you are a math student, and if you plan on taking any science like physics or chemistry or whatnot, a big part of where people struggle, and particularly again in science, is with converting units of measure. It's not a small little thing, but hopefully, I did a decent job kind of highlighting some of these concepts. Now, if you need any help with the algebra or geometry, in this particular problem, I'm going to leave links to my main courses in the description, which include pre-algebra, algebra 1, geometry, algebra 2. If you're at any one of those particular levels, you can check those courses out. But if you're not a math student and you're like, boy, I would just love to learn more about the math that's kind of going on in this particular problem, well, then check out my Math Skills Rebuilder course. I teach you a ton in that course. Again, this particular course is for people who are just interested in math. So I teach you basic math, algebra, geometry, trigonometry, and even some basic probability and statistics. Again, you can find links to all these courses in the description. Okay, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.